Okay, welcome back everyone. This is Wilco Kwak again for GeoDBMS. If you look at the lecture slide, you can see that you're doing a different course, but I'm reusing slides of this other guy, and it turns out I only have these slides in PDF. So I cannot change the title, I'm sorry, but and I'm also skipping some of these slides. So, but you're at the right place. Today, I will try to do it in 3 blocks. So there will be 2 breaks. And the first 2 blocks will be about the 2 parts of SQL that you still need to know about. And the third block will be for your assignment number 3, which is also on SQL, but there we use a special data set. And I have this special lecture to explain how this data set looks like. So I'll start again with a SQL and more SQL and then data set. And the third one is a bit more interesting, but you need the first 2. Okay, last week we did multi-table SQL, and now you can do everything with tables, but there's still stuff that you cannot do yet with the database or with SQL. So let's see about that. And the thing that you should know about is aggregation and grouping, because now you can select a lot of data from the database, but what you sometimes need to do is make the data set smaller by counting or averaging or sorting. So let's see about this. So till now we have only built queries that where the where clause is about 1 row of the data set, and the outcome is always a sort of global result. And so if you want to calculate a query, you always have to look at 1 row and then decide about that row whether you print it or not. And now we want to do queries that decide that you need more than 1 row. Let's see what we mean. So here we have the department table, and then you might want to know what was the last time a department manager has been appointed. And it's in the database because here you see the date that the manager has been appointed, and here your query might be, so if you want to know what's the last time, then you find, and this is the new part, this is the aggregation, the max. So select max of all the managers from the start dates of managers from department, and that will give you the result that you want. So this max thing is important. And then there's this one thing that we will discuss after the break, because, well, of course, it's always interesting to know which department it was that the last that had the last manager appointed. And if you try that, we can try, and we'll see what happens. Let's try this query. Let's select some text. How do I do that? Well, no, this one is so simple. I can do it without copying and pasting. So I run pgadmin. I do the query. And then what was it again? Manager start date from department. Well, it works. That's nice. But now Each department has also a department name. Let's print that too. And now it should give an error message. Yes, and it does. Why is that? Well, actually, that's because, well, we can see if you look at the table that there is only one department that has this large, where that has been lastly appointed the manager, but well, maybe that there were more which having exactly the same date. And what happens then if you want to print it? Here you have more than one value, and you have more of exactly one date, and then you have to remember that databases can only print only about the tables, and then you would have a table with one column with one value here, or one value here, and more than one value here. So it's far easier for SQL to print only the value than if you want to have to print the value with all the combined names. And after the break, we will discuss how you would do this pre-printing all the names. So I remove the max again. And for the rest, this whole aggregation is quite straightforward. This works. Same, and then there's also average. Probably doesn't work on dates. Let's try. No, average is, but it could work on department number. Yeah, well, that's basically the idea. So I go back to the slides again. So how do you do it? With the max. And then again, we discuss always the execution model. How does it work if there's an aggregate? And well, what you basically do is first you do the select without pretending that there's not a max, and then the result is a big table, and then you reduce this whole big table to one row by applying the max operator. And of course, there's max, minimum, count, sum, average, and all kinds of statistic stuff. One important thing to know is that duplicates are relevant and null values are not taken into account. So if you want to calculate all the students in a database, and it depends on what column you start counting, because if you have a column with null values, they are not counted. So make sure that if you count, make sure that you check on null values. You see that here, if you count the department numbers from employee, there turns out that there will be 8 employees. If you count the supervisors, then it would be 7, because there's this null value here. You can use more than one column. You can select the max and min salary. And here you say this in the later. So I explain how to get more data in later lectures. How many projects are around? Well, counting, all kinds of straightforward. So I'm going a bit quickly now. You can read the slides later in a slower if you want. And count star, you count the number of rows. And then sometimes if you count, you want to count the different values of how many managers are there in employee, then you have to add the word distinct, because otherwise, if you do not do that, otherwise you would count how many people do have a manager if you remove this distinct. So distinct is to count the distinct values of this thing. Also important. And of course, you can also do you can combine this aggregation together with the rest of SQL. So you can have a select and a from and a where, and then in the end you count the final result. And here you have what's the spread in salary. So you can do a max salary minus min salary, also works. So well, actually, this aggregation is quite straightforward, but then you can still do interesting things with them. You can do calculations in them. And now you think we're ready. But there's still more stuff to discuss. So how many employees are there in each department? Well, what we can do is how many employees are there in total. This straightforward query. But then you want to know it for each department. What you could do is find all the departments and execute this query or a similar query for all the departments. But, oh, this is not what you want. So you can do it for department number 5 and all the other ones, but no, this is not the way of doing it. So what you want then, and you see it here, is basically you want your table to be grouped in groups. So here you have a group for each department. Here you have the group for department number 1, the group for department number 4 is in blue, and you have a group for department number 5 in green. And then actually what you want is to do the count per group. So that's why you have this new construct. It's called group by. So what you do if you want this is to select from and then nowhere, but the group by. And you do a group by department number. And then again, what did you want to know for each group? Well, how many employees there are. So let's see what happens. Oh, well, you want to know, of course, in the result which department number it is. And this matches with the grouping, of course. And then you count them. So this is a query, this is example query of how to use grouping. And then we go to the execution model again. So, and oh yeah, this is the result. So if you do this, then you get a list of department numbers plus the grouping. And this is exactly what you expect. So 4 people in green, 1 in red, and 3 in blue. And it's an unique. So we continue to the execution model. So again, well, we start with doing the select. So we start doing this. We need to do that because if there's a where clause, we need to filter on the where. Then we group on the group by, and that basically means that if you do the group by, then the resulting table gets split up in all tiny tables that for each group you get a tiny table, and then you evaluate the select expression for each group, and that would result in that each group table becomes one line. So by the group by, you basically split your table into all small tables, and then you do the select or the and then for each small table results in a line again. And that means that the end result of your query with the group by is the table again. So well, this is kind of nice, this group by. So if you can use it in many different places. You can find employees and all their youngest relatives. Then you do an employee number of this. You group by employee, because for each employee you want to group and find the youngest relative. And well, so, and there's this one thing. So you can also add where clauses. So if you want not the youngest relative, but the youngest relative with the youngest daughter, for example, then you do a where clause. And what happens then is if you look at the execution model, then first the where clause is executed. So you start with the from, and this where, and then all the people that are not a daughter are removed, and then the group by is done, and then the result is calculated. But then it sometimes happens that you do not want all the groups in the end result. So you want only to have special end results. So you want to make a selection on the groups. And then what you do is you cannot do it in the where. So then you get an extra clause in your query. So you have select from where grew by, and then you get having. So if you want in your end result, you don't want all the groups, but you only want a specific type of groups, then you use having. So having makes a selection of all the groups in the group by. So here you have only groups that have birth date after the 31st of December of 1979. And well, this grouping is quite well useful. And then you have to know that you can also use a grouping on more than one attribute, and well, it also works quite straightforward. So here we go back to our execution model. What happens if you have a query like this? So a query with select, from, where, group by, and having everything. Well, you have to interpret it like this. First, you do a select star. So without having a look at these rows, disregarding the group by and having clause. Then what the computer does is it executes the group by, so it calculates all the groups. And then for each group, it checks whether the having works or not. So if a group discalculates to full, then the groups get thrown away. And the groups that get selected, well, what happens is the select part, so this part is evaluated. So this is the way you can understand how your end result gets calculated if you start from the query towards your end result. By the way, I do not see my chat window, so I'm going to find it so that I know whether you have feedback or not. One moment. Oh, where is this chat window again? I always lose it somehow. I'll find the chat window during the break in a few minutes. I'm almost there for this part. So again, this group by works together with joins, etc. So let's see. For one example, let's see where you find if you want to name and the social security number of all the dependents, and you could try it like this: select social security name and max dependent birth date from employee, join, etc., group by. But then we could try it. Then you would get an error message because, well, it says, let's see if we can regenerate this error message. I've heard that Postgres does not give error messages, so I'm a bit worried that we don't get an error message. No.
I think it was the previous one that gives an error message.
Oh,
right?
yes, that's okay.
It's selecting from the dependent table.
Yeah, you're quite right. No, sorry. In standard SQL, this one gives error messages because then it says, oh yes, but you're not mentioning first name and last name. You're not mentioning in the group by. So first name and last name, they may be different. You may have different first names and last names, but somehow Postgres is capable of figuring out that first name and last name always match. So in Postgres, you don't have to do this, but in many other SQL versions, you have to add them to the group by, because otherwise you can only mention stuff that is mentioned in the group by in your select part of the query. Oh, here I have a comma too much. Oh. Okay. So sometimes if you get weird error message, you have to add final attributes to the group by. And this is it for the group by part. Let's have a 5-minute break. It's 14:06, so we continue at 14:11. And in the meantime, I'll open the chat window to see where you are. After the break, we will discuss the final thing, and at the end, you will know the SQL language completely or enough for your assignments anyway. And so the final thing is, of course, is about advanced SQL queries, because there's still a few things that you sometimes want to do and still you don't know the commands yet. Okay, see you at 14:11. Okay, I'm not sure you still can hear me. I resume sharing my screen and resume recording. And I'm on the air again. First, I give an example of this group by stuff again. So let's see here, we have the simple query without any group by. Select everything from employees. And now I want to count how many males and how many females there are. And for that, we have this gender column or this sex column over here. So let's see how we find the sex. So we want to have two groups. So we do group by sex. And no, this query does nothing because, well, it will say, well, you don't have groups, or all attributes would appear in group by. So now we want to count how many there are. So count star. And of course, now we count each group. And now we want to know the attribute of each group, which is sex. So now, if it's okay, you get all the males in one group and all the females in other group. And other thing you could, well, what the computer does probably is sort. So you can choose. So here you can easily see that your end result was correct. So this is basically how this group by works. And usually if you have a database, you have lots and lots of data, and then your screen is only this small. So it happens a lot if you have lots of data that you use this grouping thing to reduce the data set to something. Oh, I see your question, Caroline. Well, you will need the groupings when you need the groupings. And now I finally understand your question. I will assign the groups for the assignment number 2 right away after this lecture. So somewhere before dinner. Thank you for your question. And I waited a bit because I understand there are some students that have registered for the assignments or for the lectures, but they're not participating. So I will have to make some groupings where students who are not doing the assignments will not be assigned to a group. So I will try to do that after the lectures. Okay, so this was the grouping stuff. Now we go to the advanced lectures. Advanced SQL. And here there's lots of stuff that you don't need to know about, but there are in the slides. So now I will discuss only 3 things in this part number 2 of the lecture. And those 3 things are views, subqueries, and set theoretic operations. I only do the not in. And that's because basically exists and for all, they are synonyms for not in. If you know this one, then the other ones are just there for fun. Okay, again, we go discuss stuff that you cannot do yet. So then we know why you need it. So we discussed this thing about the names of the oldest employee. Why can't you do it with the group by? Well, if you do a group by, or if why can't you use the max? Well, you can do the max, but then you only get the birth date of the oldest employee, and that's not enough. So, and there are similar kinds of queries. So let's figure out this name of the oldest employee. Well, the problem is there may be more than one oldest employee. So it is basically the names of the oldest employee. And another thing you cannot do yet is the average salary of employees working in Stafford, because then what you need is, well, you could do it like this query. You think that it works, select average salary from employee that works on projects in Stafford. But this query does not what you expect it to do, because what happens here if you do this query, if a person works on 2 projects in Stafford, the person gets counted twice. So, and that's not what you want. So you have to do it. Oh, then you think, oh, if something gets counted twice, then you always can ask this distinct work, because then it gets reduced to once. But that doesn't work. So you have to do it basically in 2 steps. Or this one, also interesting. Find me find me the department having the most employees. And then what you basically would need is 2 aggregates, a max, around to count. And if you try that, it doesn't work. Somehow SQL doesn't allow this, so you need another trick to do that. And it turns out that there's all this stuff you still cannot do, but there's only one trick you need, and that's using views or subqueries. Let's see how it happens. We start with the views, and let's start with this one, the name of the oldest employee, or the names, because there can be more. It was discussed. Well, how would you do it for yourself? Well, if you want to try this, well, you usually split up a problem like this. You split it in 2 parts. So the first thing you do is, well, let's see what the oldest employee is, and you can do that. That's it. Or then you would turn out that this is the age of the oldest employee, and then well, if you know the value, then you could fill in this value in this query, and then you would get the names of the oldest employee. So you can do it in 2 queries, but that's not so nice, because in the meantime, in the middle, you have to copy and paste. And so it would be nice if you could do it in 1 query. So, and there's a trick for that, and that's called a view. So suppose we would have at our disposal a 1-by-1 table. Let's say that table is called min.dat, and that one always contains the birth date of the oldest employee in the database, whatever data is in the database. Then your query would be select first name from first name now from employee that, and here you join on a 1-by-1 table, which is a bit tricky, but that basically means that min.dat equals to the birth date that in the table. So this will do the trick. And then it turns out that you can create a 1-by-1 table with min.dat, with the age of the oldest employee, by creating a view. So this works like this. So there's this new SQL statement: create view min.date as select min birthday from employee. And this basically constructs a virtual table. So a table that is not really in the database, but once you query that table, it gets calculated. And you can use it in any place where you would use an ordinary table. So how would you solve the query then? Well, you would first create this view, then which creates this virtual table. Then you would use this view to calculate your answer, and then in the end, to keep your database clean, you drop the view again. Let's try that in practice, over how the real works in reality. I like to copy and paste from this one. So I copy. Somehow I cannot read this. So I insert. I did strange stuff with. So there's one trick that you need to know about SQL or GeoDBMS. So if I want to only execute one part of your query window, you can select it. I think so. I first now execute this part. So create view. It has been created. Nothing happened. But now, if you would try select star from and min dot. Here you get the age of the oldest employee, and now I'm using this min dot, this tiny 1-by-1 table, to do the selection. Let's see where it goes wrong. Should it be natural here? There is still a difference between. Anyone a suggestion? I know what I'm going to do if it doesn't work. Because I'm going to, oh, here, space is missing. Ah, always happens. No, this wasn't it. Let's read the error message. Oh, maybe the natural should go away again. Ah, finally. Okay. So, well, it's only not only you that is having trouble when you type a query and it doesn't work. Oh, where is my problem? But it always happens to me. But reading error messages usually help. So this is the name of the oldest employee. It was a lot of work, but it worked. And in the end, to keep my database clean, I dropped the view again. So let's do that. And now, of course, if you want to do all of these together, I just removed this one because it was. I do them all. And you don't see anything because it only shows the end result of this one. So I do it in 2 steps now. I create and the select. And then just for cleaning, I drop it. Okay, so this is how views work. So with views, you can make virtual tables that you can use to combine 2 problems. And well, thank you. I see now in the chat window that somebody suggested the space. Thank you, Chris. I should check my chat window more often. Or maybe if you see me doing something stupid, you can break in and talk to me directly. And then again, if you do this, please use meaningful identifiers, because if you name your views test 1, test 2, test 3, and then 1 day or 2 days later, you want to understand what you were doing, and then you're lost. So please give meaningful names, yes. And the question, so to create views, a view is a way to create a temporary table from the other tables. Yes, basically yes. So you create a temporary table, and the interesting part is it gets automatically updated, the view. So if you create a view and then you would delete the oldest person from the database, then automatically the view gets updated so that it still shows the oldest person at the time that you do the query. So views are not copies of the data, but they are updated automatically when you change the rest of the database. And this is where I go a bit faster than in the, I skip some slides because I think, well, if you know the idea of this view, and then you can relax it, then you can, well, if you get the idea, then you don't need to see all the other examples. So you can use this view in a lot of ways, and the pattern is always the same. If you have a problem that you need to split in two parts, then first you create a view that does the first part, and then you do the query on the view, and so this query on the view does the second part, and then you drop the view again. And here you do it who earns above average. You first make a table of a view that calculates the average salary, and then you use that view in your final query, and then you drop the view again. Same employee of having youngest dependents all. You create a view again, and this one is nice because it contains an aggregate, and then you use that view in the selection. And well, this one looks a bit tricky. But well, if you look at it carefully, you will figure it out. And you need this thing here. And well, views becoming more and more tricky with parameters in them. Yes, so I'm skipping all of these because I think you can have a look at them in your own time, and most of the times it works. I think there's one thing I still need. Oh no, not even that. The department having the most employees. Oh, you can also create two views and use the query then and drop the two views again. After you drop the view, it's not accessible anymore, and then the view doesn't exist anymore. So you can create it again. So this was views. This is topic number 1 of the advanced SQL. Topic 2 is subqueries. This subqueries is about actually is about the S of SQL, because SQL is a structured query language, and you can basically make queries within queries, and well, that can also be useful for finding the names of the persons, for example, or the oldest employees, and I'll show you how. So what's the idea of a subquery? Well, basically, if you have a query in SQL, and that can be any query, and if this query would yield in a 1-by-1 table, then on all places where in the SQL language you need a value or a 1-by-1 table, because a value is basically a 1-by-1 table, then you can put the query between brackets on the place where you want, on the place where this value should be. So let's try this again for this oldest employee, or what was it? I move my window back in. So can we do this oldest employee in a different way? Now let's start. This is basically the query. that gives the birth date of the oldest employee. Let's see whether it works. What's happening now? Oh, yes, it comes. So this is and this query results in a table of 1 by 1 column. And now I want the last and the first name of all these persons. So I remove this and this from, from we already have. And now where birth date equals, and then basically we want this value. I think it should be these quotes. Oh, now I've done not enough. Okay, so this is it. But now I want to combine these two. Well, what did it say? Well, if you have a value somewhere in your query, you can always replace it by a query between two brackets. So that I do now. I put two brackets here. And then between those two brackets, I put this query. And now I have created this nested query. This does exactly what you want. Let's see whether it works. Same algorithm again, so it's not so surprising. So this is basically the idea. In any place where you have a value in your query, then you can always replace that value by a query that returns a value. Really convenient. And what can you do now? Well, again, the names of the oldest employee. That's what I show to you. And here you replace this value by another value, by a query. And well, so you did it with a create view, but you can always also do it like this. Nice trick. And then it turns out that basically what you have here is you use bdate twice, and that would result in a name clash. Like if you use the same variable in Python in two pieces, but because there's two brackets here, this bdate only is known this variable name between these two brackets. So you have, like Python programming, you have sort of block structure, and variable names are only known inside the block. Similar queries again, that means there's more examples of the same. Who earns above average? You can use a nested query again, or you could do it with the create view table, but you can also do nested query. Because here there's between brackets the nested query. And the youngest dependent, you could do it with a view, but again with a nested query. So every time you use a view to make a 1 by 1 table, you can get rid of the view and use. Oh, my phone is ringing. I have to switch it off. It's my other job. I should have switched it off completely. So again, employees having the youngest dependent of all. You could use this nested query again, and even nested query where you match social security numbers. This one is most trickiest. And what sometimes happens, and then we get to the final part of this advanced SQL, is sometimes the subquery does not result in one value, but it results in a row of values. And then here you would say, because this subquery results in a row of social security numbers, and here you compare social security number to a row of numbers, and of course one number never equals a row of numbers, So then you would need to say not equal, but in. So here you say in, that means where this social security number has one of the values, so not equals, but has one of the values here. And so in operator yields true when the left-hand side occurs as one of the rows of the right-hand value. And of course, you can use the nesting and the views and the subqueries together in a mixed way. Well, lots and lots of more examples. They're becoming more and more complicated. Well, and I know that usually during your assignments, you know how to figure it out. This assignment's getting more and more complicated, and your mind grows together with the assignments, and your queries become easily as complicated as this one. But during the assignments, you will easily do it, and now seeing it during the presentation is harder. And then there's two things. So this department having the most employees, I'll go to that one here. It's lots of views. But if you use a combination of views and nested queries, it becomes more easy. And you could do it even more complicated by doing two nested groupings, but this one doesn't look that nice again. So in many cases, and that's what you see with SQL, there's lots of ways of solving the same problem. And sometimes the result is a query that nobody understands. And then sometimes it's better to find a similar query or that is easier understandable, because in the end, it happens a lot that after a year you have to reread your own queries, and then you figure out what did I mean here. So it's always good to take some time to make queries look simple, even if they do what you expect them to do and they are complicated. Okay, now a final part about set theory, in and not in. It was already discussed. It's another thing, and this one you need definitely in assignment number 3, so next week. The in checks whether a tuple is inside the table, or checks when a value is in another column table. So for example, find all employees having dependents. That's okay, that is doing this one. But then if you want to have the names of employees having dependents, then what you do first is here you have a query, subquery, that finds all the names of all the social security numbers of persons having dependents. And then around that you have a query that gives me all the names for employees where the social security number is in, and then all the social security numbers having dependents. So if we try this one, you don't even need this thing here. Copy. Let's see whether the query works. Space again. Thank you. Same as last time. Oh, this copy paste thing just removes spaces somehow. Again, hi. Did I miss more spaces? No, I don't think so. Okay, the query works. And now, why does it work? Well, this part of the query, which I can, by selecting it and by pushing the play button, I can do only that part. So this part of the query gives this list of social security numbers that have dependents. And here by saying find all of them where the social security number in this. So, and so I'm making a sort of combination now. What you can also do is instead of doing a query here, I could do numbers like 3, 3, 4, 3, 4, 4, 5, 5, 5, 5. Well, let's do 2 numbers. 10 doesn't exist. Oh, did I forget about SQL? Okay. I should read error message again. Apparently, social security number is a character in the database, so I should put quotes around this, and then it should work. Let's see. Yeah. The other way of solving it would be like this. I could convert the social security number also to a number by putting int around it. Oh, no, different. I'm using the wrong language. Converting to an integer works like this. Yeah. Okay, just to show you one of these things you can do, of these nice things in SQL. Okay, I go back to the presentation again. We're almost there, I think. So now you know what in is and how you can use it. And you can use it in all kinds of different ways. And the opposite of in is not in. Value where the value is not in the list, also useful. You could use it, of course, if you want to have something without all the dependents. And then exists, well, it says exists is basically similar, or is in a exist and not in are interchangeable, so I do not have to explain it. And for all, we are not using it in the assignment, so I'm also skipping that. So I'm a bit tired now, but basically now I've taught enough about SQL for you to make all your assignments. So good luck with that. So let's have another break now, and then after the break, I will give you a presentation that I gave also, I think it's almost 10 years ago now. I have to check on a data set we created. We put in this city of Delft, or the students put lots of Bluetooth scanners, and they scanned, or they collected lots of data, and this data you're now going to use in your assignment. And so this presentation is just to show you what the data is about. And I will start with the presentation in 5 minutes. That means 14:50. Okay, see you guys in 5 minutes. Okay, guys, I'm back. Finally, we're done with the SQL thing and the complicated commands. Now I'm going to give this talk about this data set that you're going to use, and it's a sort of actually it's a presentation I gave at the conference, and in this conference, all the research that we did, I did with the SQL language. So it's a nice sort of way of showing, well, this language is not so bad at all. So let's see. What did we discuss at the time? Well, the idea was in this research, it was about tracking moving people. How do people move to the city? And then at the time we knew two tricks of doing it, and one was Bluetooth. So well, you know, all of your phones, most of the phones, they have Bluetooth, and many people have it switched on. And if you have Bluetooth switched on, what you basically do all the time is wherever you go, you broadcast your Bluetooth identifier saying, I'm here, is there someone here, or a phone or a printer or speakers that want to connect to me? And so if you have a scanner device that just listens to people broadcasting their Bluetooth signal, you can count them quite easily, and that's nice. and it results in maps like this. They're called heat maps, and they are helping tracking people. But well, if you see on the heat map, you don't exactly where people are, etc. You only know that they're close to a Bluetooth scanner, and you have not Bluetooth scanners everywhere, but you place them in different places, and you don't know what happens in between. But then there's GPS, and if you could give people a GPS, well, you get maps like this. You know exactly where they are moving and where they are going and where they stop and where they continue. And so actually, what you want, if you want to know where people are, you want the nice parts of Bluetooth and the nice part of GPS, and that's what we tried in this research. So we had the Bluetooth scanners, or we had 30 or 40 of them, and well, it's a sort of device, and you put it in the plug it in, and you put an antenna on, and you put a Bluetooth stick, and then what it does, it basically counts all the devices of persons that are passing by. And it was a student project, and the students were really enthusiastic. So they went to all the shop owners in Delft and tried to ask them to whether they were willing to put a scanning device in their shop. And well, we put them there for a week, and we also put one at architecture. So it's nice because this is the entrance of the campus, and we hoped that in this way we could count how many people were passing by going through the campus. And there's one at the station, and there's one at other strategic places where you have to cross the river. So by putting the scanners there, we hoped that we could get a nice coverage of the city of Delft. And well, it basically worked. So here we have two data sets, and this one is, we counted everything between 8 and 10 in the morning, and then you see, well, people are working there, and it's not so busy at the city center. And between 3 and 5 in the afternoon, it turns out that the places where you can have a beer, they're a lot more busy. So it would be really nice to redo this experiment during Corona crisis and see whether the measures they help. So this topic is still actual. And now these Bluetooth devices are nice, so they're easy to set up, and you don't have to ask people to work with stuff for interaction. You just count people even if they don't know about it. So whenever you get this privacy course, or then you should be really careful with data sets like this. And the nice part of Bluetooth, it also works indoors. So GPS does not work indoors, but Bluetooth does. And it also has disadvantages because, well, making a heat map that represents reality is really hard. And why is that? Well, because you don't know the effective range of a scanner. And there's a big difference between a narrow street and a square. And you don't know anything about routes people are really take. So if you go back to the previous slide with the heat map, then it turns out it looks as if it's really busy here and not so busy here. But it turns out that in the end, it was not that it was really busy here, but it turned out that the scanner that was over here was much better at scanning than the other scanner. So the scanner over here, it could scan everything in a circle like this. So these heat maps, they're really tricky, and we needed some way to figuring out whether this map is a representation of reality. And as you can see in the final slide, that having these GPS has also helped in that. So the other thing, GPS logging. Well, these days you would do it with the mobile phone, but this was some few years ago, and instead of people having their mobile phone switched on, we had these tiny black devices, these GPS devices, and you had to switch them on. And if you switch them on, they were recording for at least a day. And we were giving these devices to test persons. The output is this. well, this is not a map, or well, basically this is a map, or this is just a bunch of GPS logs drawn on a white piece of on a white sheet. And but already, if people see that this is a map, because well, you can see here's architecture, there's the bridge here, there's the railway station here, and as far as I know, so GPSs, they really give detailed output, and so they give lots of details, but it doesn't work on indoors. And well, if you want GPS logs, you have persons to give these devices to persons. So usually you work with volunteers, and that's a bit tricky because there's not so many of them. And it's a tough job for a volunteer, because I remember when we were doing this with these devices, we had also had sort of we provided them with stickers at the door. If you go outside, don't forget to bring your GPS, etc. So it's nice, but it's a lot of work basically. So then we had the idea, let's combine the two stuff, and we did it together with Ghent University, and we had a students project that was Delft from above. And what we wanted to know, that was the assignment that the students had, were figure out where civilians and students meet. Well, because well, we all know Delft is a student city, but still, the majority of the people in the city, they are civilians. And well, I don't know, but sometimes there are conflicts between students, and you want to know where they meet, etc. So we try to figure out whether we could find out where they meet. And for that, we had these 31 Bluetooth scanners. We placed them at strategic positions. And we had this 74 GPS devices, and we divided them among civilians and students. And they logged every 5 seconds, they logged their coordinates. And we did this experiments for 10 days. And after the 10 days, we wanted to combine and analyze the data and see whether we could get anything useful from them. So this is basically what we did. So we combined the data sets, and then it turned out that there was one thing was really nice. I'm not sure you can see it, but somehow on this GPS device, it turns out also to be a Bluetooth device. And that was nice, because then we didn't only have this 2.8 million GPS track points, and we had 600 times scans from Bluetooth devices, but we had also 2,000 matches when one of the Bluetooth scanners saw the GPS device. And that's nice, because then you have a sort of link between the two data sets. So 2,000 times it happens that the Bluetooth scanner saw the unique identifier, because all these devices have a unique identifier of one of the GPS devices. And that's link we really needed, because well, when we started to look at the data, it sometimes looked a bit weird, because what happened is this. Here you have the architecture building, and here you have scanner 316. And then what we did is, because we combined the two data sets, every time the scanner saw one of the GPS devices, it writes in its log, at exactly this time I saw this Bluetooth GPS device. And then what we did is we checked in the GPS log of this device, where were you exactly on the time that you were seen by the Bluetooth scanner. And then hopefully what you would expect is that in all the cases that GPS would be in the neighborhood of the Bluetooth scanner. Otherwise, something is completely wrong. And okay, we did that. This is the first thing we tried, and then it turns out, well, in most cases, and when the GPS was seen by the Bluetooth scanner, it was quite close to the scanner, but a lot of points were also quite far away. And well, then you start reading documents. Is this okay or not? And then according to the documentation, wow, in nice circumstances, um, the GPS or the Bluetooth scanner can see devices, wow, maybe 10, 20 meters or so. So what we would have expected here is a circle of around 10 or 20 meters around here, and not like this. So we figured out something is wrong. And now the question is, does any of you have an idea of what went wrong? You can type it on the chat. Or there's nothing there yet. So does any of you think that it was the GPS device that has bad accuracy? That was my first thought when I saw this data. But no, the answer is no. Well, because why not? Because, well, if you it's not the GPS device having bad accuracy, because then you would expect these points to be randomly distributed, and they're still on the street, so they're probably quite okay. The signals were erupted when people were inside the buildings. Yeah, might be the case, but I'm not sure. Not so much. I think you just if the GPS is inside the building, you just didn't get any response. But yeah, so let's see what it turned out to be anyway. Is that the clock of the Bluetooth scanner was wrong. So we thought, well, clocks are always accurate these days, but it turned out that the clocks, they were not synchronized at the start of the experiment. So the clocks were just minutes off sometimes, and well, that would be easy, because then if you know at the end of the experiment, you know, oh, the clock is off. Let's compare the clock of the Bluetooth scanner with the clock of the GPS device. But it turned out that also the clock was skewed. So every day, the clock of the experiment, of the clock of the scanner, was another 10 seconds more off. And how bad is that? Well, it depends a bit on what you want to do with the experiment. But in our case, it was really bad, because, well, what we actually wanted in this map is to see the range of the scanner. So I wanted to know how big is the circle around the scanner, where you can see, or where the GPS is seen by the Bluetooth scanner. And, well, with the current data, it didn't work. So we need a way to figure out how to fix the clock. By the way, when we figured this out, now we know that we have to synchronize the clocks more regularly, and we would do it in a different way. So, but then we tried to find a way to calibrate the clocks, and we basically did it in 2 steps. First, sort of coarse grain calibration. I looked at the GPS, or at the device, and see, oh, well, this one is 10 minutes off. And I did that till I knew that most of the clocks were at most a few minutes off. And then we started to do this other trick, because, well, what basically happened is, how can you tell whether the clock is off or not? Well, it turned out that if the GPS device was close to the clock, to the scanner, and the clock is wrong, then what's happened is, well, first the scanner sees GPS device, and then 2 minutes later in the log of the GPS device, then you see, oh, now the GPS device is moving close to this scanner. And maybe I don't know you're following Edward's course right now, but the clock in a GPS device is by nature is always exactly right because GPS devices need an exact clock. So we could fix the clock of the Bluetooth scanners by checking them, seeing, well, if this GPS device is seen at this time near the scanner, and we know from the log that 2 minutes later it was close to the scanner, then we know that the clock of the scanner is 2 minutes off. So that's basically what I did. I did this lots of statistics, and actually this was the only part that I was not using SQL language for solving the problems, but the R language. But I did some statistics, and it turns out that here I compared the clock of the Bluetooth scanner. I compared it with the time when the GPS device was close to the Bluetooth scanner. And by comparing this difference and doing lots of statistics, I could figure out this is the difference. This line is the difference between the clock time, the clock of the GPS and the clock of the Bluetooth scanner. And by this helped enough to fix the clock of the Bluetooth devices. So, well, now I knew in what way the Bluetooth scanners were wrong, and I fixed the clock. And it turns out that it worked because, well, this was the original data, and then by fixing the clocks, we ended up with this. And this looks a lot better. And so now you have an idea of the Bluetooth scanner that is over here can basically see this region, and well, that's a bit more logical. And then, well, here you see these 5 or 6 outliers, and this is probably because of the GPS having a reflection or so. So fixing the clocks really helped and gives lots of extra information on where on the quality of the Bluetooth scanners. So now we have, and that's a nice part. Now we have 2 data sets. We have the GPS data and the Bluetooth data, and now we try to combine them. And we did some nice tricks with them. So one thing we needed to know is how far do these scanners, how well do they scan? And then it turned out that there's a big difference between the scanners. So over here you see the scanner 102 near the old church, the Leaning Church of Delft, and it scanned lots of points. And over here there's a scanner. I can't even find where the scanner is, but it's somewhere over here. Also doing a good job, but over here there's a scanner, and it's scanning on the big square of Delft, so you would expect lots of points, but no points there. And especially this one, it didn't do a thing basically. So and actually we didn't know that in advance, that there was such a big difference between the scanners, because if you look at this data, then you can be sure that this scanner is just basically wrong, and that is quite hard to figure out if you wouldn't have the GPS data. So that was one thing we tested. And okay, here you can see I'm not a cartographer, I'm a computer scientist, and I know how to draw data, but I don't know how to make nice maps. So I just plotted lots of points, and in this case the green points are the points where a GPS device was seen by the scanner, and the red points are all points that were in the GPS data set, but they did not match a scan of the Bluetooth scanner. So I think the Bluetooth scanner was somewhere over here, and you see here all these red points, meaning that in all likelihood the GPS device or this device was really close to the scanner, but was not seen. So it turns out that sometimes you're counted and sometimes you're not counted, and well, that's also interesting to know for statistics. And then we also tried, let's see what happened to people that past the scan point 322, which is over here, and where did they go later? So you get a sort of idea of what happened, what people really did, instead of where they were seen by the scanner. And it then turns out that, well, from moving from 322 to 101, most of the time people walk directly, but sometimes it happens that if you go from 3 to 2, then it happens a lot that you're seen by the scanner 309, but what route you take, you don't know. But if you now see that most people take this route, you can make assumptions about the other people, what they're doing. So having a map of seeing what most people with the GPS do helps you interpolating what other people might be doing where you don't know exactly. Okay, well, now for your assignments, you're going to load this whole data set into Postgres and do your own queries. And you could do all the same queries I did, but that's of course boring, and you could try your own queries. So go ahead, make your day. If you are feeling confident about SQL, and you can do nice stuff. And then the question, are these queries that I did, are they really complicated? And the answer is yes and no. They're all SQL, and most of them you could do, but some cases I use this statistics part of SQL that you don't know about, and I use this polygons part. But most of the queries there are really straightforward. So please go ahead during the assignments and make your day. Have fun with the data. So as a conclusion, well, Bluetooth combination and GPS, they're really nice. You can use useful stuff. And then this one final question is, why did you do everything with SQL? Well, because, well, I know more languages than SQL, but I'm quite proficient with SQL. So most of the time, if I have the choice to do it in any language, I use SQL. But I can imagine that you've been doing Python in the quarter before. That for now, quite Python is would be your tool of choice. And well, yes, it's up to you. But for your assignment in this course, please use SQL, because in the end of this course, you know at least two languages, Python and SQL, and well, they're both convenient for different. Or it's nice to have a toolbox with not only hammers but also other tools. And so please do your best with SQL, and then you have at least tools in your toolbox. Okay, hope to see you this Tuesday or this Wednesday with the practical courses. Please let me know if you have trouble with installing the database, because I heard that some people had trouble. Well, just please let me know if it doesn't go right. I try to fix it. Okay, good luck, and see you in 2 days on Wednesday. Bye-bye.